All right, everyone, welcome to the Maxon booth here at NAB 2024, and we have a lot of exciting updates. Just announced was the new Maxon release here, just April 9th, I think it was, just a couple days ago. So to my left, I have an amazing educator, artist, developer, and business owner of Rocket Lasso. Please put your hands together, make a lot of noise online for the one, the only Chris Schmidt, everyone. Woo!
All right, testing. Okay, seems like we're good. All right, so let's begin with, hello everybody, I'm Chris Schmidt from Rocket Lasso. I want to start out with a question. How many people have maybe checked out part, I don't expect you to have done all of it, but at least part of my What's New 4-hour-long video? Anybody? Oh, wow, okay, excellent. More than half the people have at least checked out a little bit of it. So my plan today is going to be essentially to continue where I left off from a lot of that, because it was a 4-hour video. We talked about particles for 3 hours. I could have talked about it for another 3 hours easily. So the plan now is to break down some of the project files I teased at the end of that presentation. But before we get there, I'm terrible at promoting the company. I'm terrible at social media. So the best I got for you is, hey, we got an NAB sale going on. So if you just search Rocket Lasso, find us on Gumroad. If you use the code NAB 2024, you get 25% off of all of our tools. I'll flash this up on the screen a couple more times as we go through. And besides that, if you're not familiar with Rocket Lasso, I do tutorials for Cinema 4D. I always do the What's New videos every year. And then we make plugins for Cinema, so we got a whole bunch of different tools. I'm not going to cover any of those in this video. It's all about the new particle stuff. And of course, I do live streams, and live streams for Season 6 have just begun last week. So as soon as I'm back from NAB, we're going to be doing live streams again, where I answer questions live on YouTube and on Twitch. So just search at Rocket Lasso, and you'll find all of our stuff on all the different channels. But today, what we're going to be doing is continuing with the particles in the new 2024.4 update. And as you saw in the 4-hour video, that's twice as long as any What's New video I ever made before, because this is the most new stuff ever added into a single version of Cinema 4D since I've been making tutorials. So it's very exciting. There's so much to do, so much to tinker with. And you know what, we're just going to be kind of winging it, like playing around with whatever project sounds good for me going right now. So I'm going to start out, as I usually try and do, and start out kind of slowly, and then kind of ramp up crazy at the end. So hopefully there's a little something for everybody here, and everybody watching online. Hi, everybody. So let's go and jump into my first scene file, which is essentially blank. And the first thing I want to mention is I've made my own custom layout here with all of the new features. But if you don't know how to make that custom layout, then I'm going to click on Standard here, and then all the new particle stuff is going to be living underneath this Simulate menu. Under Simulate, you're going to see we have our new emitters, and I'm going to tear that off. And then under Simulate, we'll also find our new groups. And then we've also got, and I'm going to put these in order, because I don't want to lose said order. And then we've got our conditions, very powerful. And then lastly, our modifiers right there. Okay, so if you want to modify your layout, and this goes for anything you want to do, just not only particles, you can right-click anywhere, pretty much on any button in your interface, and say, hey, I want to customize my palettes. And once you've done that, it's going to pop this open, and you see all of your different layouts have been highlighted. So now you have the ability to move buttons around and rearrange things. So in this case, I could grab this entire modifiers stack and drag it over right next to my viewport, and now those will all be living there. And then from there on, I can just manually drag all my different pieces over. Oop, let me make sure I grab the right spot. And I can drag these into different locations and swap them from spot to spot to spot. So I'm not going to spend time like completely rebuilding that, but now you can see how I did do that. So I can go back to Window, and you would want to, after you've done it, go Window, Customize, and then you're going to say Save Layout As, and I did save the layout as Particles. So I click on that, and you see I've got all the emitters, all the basic stuff, and I also put in the forces as well. We'll definitely be using those. So, whoop, I accidentally made a HUD element here, so I will remove that. Okay, so starting out real basic, for anybody who hasn't seen that we have new particles now in Cinema, we've got 4 different types of emitter. We've got the basic emitter, mesh emitter, and the spline emitter, and all of them share a lot of properties. I'm not going to go and step through all of them. And the 4th type is called reproduce, which is essentially emitting particles from other existing particles. So that one's very powerful and exciting, and we'll definitely get to play with that more this time. But we'll start out with some super duper basics. I'll pop open a basic emitter, and we don't need to, well, I'm going to delete the figure because we don't need them anymore. But just as a heads up, in a lot of my files, you're going to see I create this figure because it's constantly giving me a reminder to work in real world scale. Like if I make an explosion in one file and then I make a cool, maybe like fluid-esque sim in a different one, I want to make sure that those are all compatible later on if I copy them into a proper project when the client calls. So putting a figure in here always reminds me of like, oh, work at real world scale. Okay, so deleting that figure, you can see now I've got a basic emitter, and it also at the same time created a particle group. In the old systems, the emitter was the particles. You would link to it, you put the tracer on it, you do all the stuff directly from your emitter. But now, all your emitters are decoupled. They just birth the particle, but the particles actually live in their group. So let's move into this next file, where again, just a figure. And the idea now is, yes, we can go and create particles, and we'll do that just by creating a basic emitter, and I'll hit play, and this is what you get right out of the box. We get some particles flying through the air. I can click on the group, and you get some properties there, but here's a preview that we can do. So I'll keep on setting this up to 2, just so you can see it better, and the live stream can see it better. Basic emitter, spitting out particles. Now, all of our actual changes to the way these behave are going to be inside of our basic emitter. Right now, it looks almost identical to the classic emitter, but right now, if I were to do something like try and render these, you will see that out of the box, if I go to Redshift, and we give it a second to initialize, you're going to see that it is rendering particles right out of the gate. That's only in Redshift, but this entire section is all about kind of making your particles real. How do you actually make them renderable somehow? So here's my thought. Yes, they render out in Redshift, but you don't get much control. Yes, you could make a brand new material, and if I drop that onto the particle group, remember, everything's in the particle group. I'll go to my emitter and I'll say, hey, let's make those particles way larger. So under radius, I'll twirl that down. And here's a new thing, if you're not familiar yet. Inside of the properties, there's like so many powerful settings that it would just eat up too much interface. So a lot of the properties have gotten hidden under these little twirl downs. So I can say, hey, I want my radius to be 5, but I can twirl it down, and we get a secret parameter of adding variance on top of it. So now I'll say a variance of 3, and that's both subtracting 3 and adding 3. So this is now anywhere from 2 to 8 in the radius size. So let's just run that simulation again. And here in the viewport, we're now actually going to see, let me start it from scratch, hit play. You're going to see these particles are showing up, but they're not representing the radius. To show the radius, you want to go into your particle group and actually say, show radius. And now there's going to be a little circle drawn around. You see I get that variation along them. But now that I've given those some variation, let me zoom on up and then hit Redshift to tell them to render again. And you will see that, look, we do have we got little spheres rendering by default, and we got all the different radiuses. And you see I applied this material, and that material is getting applied. But I suggest that you don't render it directly via your particle group. What you'd like to do is right-click and instead add in a render tag and add in a Redshift object tag. That will give you access to this particles dropdown, and now I can tell it to not render, or I can say, hey, give me point instances, and now they're going to be perfectly flat. We can do sphere instances, which is what I think it defaults to. We can also do quad instances and just get perfect flat planes. Anyway, you can see that we can do custom objects. You can feed in a whole bunch of different objects in this list, and they'd automatically show up in your renderer. So that's just a more controllable way of adding your Redshift tag. But we are not limited to just Redshift. There are other ways of sort of thinking of the particles and making them real. So one thought is, what if we wanted to make these into geometry of some sort? Actually, no, before geometry, why don't we also do a tracer? So I added a tracer to my interface. So I've got the particle group selected, remember, not the emitter, and I click to create this tracer object. And actually I will say from end and limit it to 22 frames worth of a tail. So now if I hit play, you're going to see that instantly we get tails there. And you can do all the rendering of a spline that you would normally do. You could sweep it, you could add a Redshift render tag onto it, you could use sketch and tune, you could use hair, and you could just render those as you normally would. So that's the second way of rendering particles, is turn them into a spline of some sort. And of course that can get a lot more fun if we add in a modifier like a turbulence. I'll set that to 2525. And now we'll just get these drifting around a little bit more randomly. And of course we get the tails traveling, doing their own thing. So yeah, I love being able to just add the tracer and get those lines on there. Next up, let's turn these into some sort of real geometry, keeping it as simple as possible. Even right now, as we're just spitting these out, I'm going to say, hey, let's create a volume builder. And then I always like to, well, yeah, so we get the volume builder. Now, typically, a workflow I would do would be drop this as a child of it, but I don't think you actually want to drop it as a child. You can get, if you turn off the volume builder, it'll actually turn off the particles. So it's better to actually remote link into it by dropping it into your objects tab. And now you see it is creating the volume. We feed that volume into a mesher, and now you see it's actually made geometry from it. And of course, you can do all the normal settings inside of a builder where we could drop the voxel size to increase our resolution, see that a little bit more clearly. And if you click on the particle group, you'll get a couple settings from here. To me, the most important one is that we can use the particle size. So if I activate that, the relative scale of each of the particles is actually represented here in our volume builder. And we'll be using that to our advantage a little bit later in a different project. So yeah, there we can use the volume builder in the same way. And yeah, I'll introduce a different aspect of that in a little while. And then the last way that we can actually make our particles be kind of real in the scene is we can generate geometry on them. So in this case, let's hit R for our rotate. I'll spin this down 90 degrees. Oh, sorry, I got to do the emitter. I want to change the emitter. And the reason that the emitter and the particle group are separate objects is that you could make more than one emitter and have them all live in the same group. In fact, why don't I show that? I'll just click to make another basic emitter and hit E for move, scoot that off the side, and this time I'll say, hey, make some particles, and I want them to have a color, and I'll set the color to be just red. So if I play right now, we're going to have two different groups, well, two different emitters and two different groups. But I can delete out that new group I made and say, hey, this one, I also want you to go into that group. So now if I hit play, you're going to see that we have both red particles and green particles as the same group. So we could affect them in the same way, use one tracer to control both of them, use one volume to control both of them. So yeah, groups and emitters are decoupled from each other, which just gives us a lot more options. Anyway, so now we've got this one emitter, and I want to make some objects. So instead of them making some sort of like geometry modifier or generator, we just use all the built-in cinema tools. So in this case, let's just make a nice simple cloner. In the cloner, we'll set that to be in object mode. What object? The particle group. And when I drop, yeah, so we've now dropped in the particle group. Now let's create a couple of shapes to drop in. So I will create, yeah, we'll use an Icasa, and I'll drop that as a child of the cloner. And I'm going to set the radius to 1, because we know the particles are kind of naturally at the scale of 1. So if you make your geometry 1, it'll kind of match 1 for 1. You don't have to, but it's just to make it visually match. But I don't want to stop there. Let's make a duplicate. And because we got all the power of the cloner, we can make all these different shapes on it. So let's say we do a hexa and an octa and a dodeca. So we get all these different shapes. And now I can say, hey, I want to use the particle scale along with it. And now you see those are going to scale up to match the particle. But even beyond that, we can go back to the original emitter and say, hey, I would like your color not to be constant, but I want it to be random. And I love the way that this color is implemented, because we get access to, we've got random, but we got a gradient. So it's going to randomly choose your color from the gradient. So now we can scroll down and get all these lovely presets. So I say, give me a full range of all the colors and choose randomly from that. So now if I re-emit my particles, you're going to see that we get all the colors automatically translated through the cloner into real geometry that we can do anything we like with. I think I'm going to scale these up a bit. So I'll go back down to my radius. I'll say those will go up to the size of 11 with a variation of 5. And this time, why don't we use the classic bullet sim, and I'll create a floor object and scoot that down. And I'll say, okay, floor, you're going to be a bullet collider body. And now we'll say that the cloner is going to be a bullet rigid body. And now if I hit play, you're going to see that we now have simulation automatically working in our scene. And all of these are flying. They got the color. They're falling down on the ground. We can just keep making more and more and more of these as we go. We can increase our timeline here. So you can see that we get all of the power. You know, I just love that we get the power of the cloner on top of these new emitters and these new particle groups. And then here's the best part. I know it's getting like a little bit more specific and technical, but if you ever played with the old particle systems, you know, of course, oftentimes you want to limit the length time, the lifetime of it. So you might say like, oh, it's going to live for like 50 frames. And then if you were doing this type of cloning onto it, if the first clone died, then it's like, oh, well, ID1 disappeared. So the next particle will become ID1, and your shapes would like pop all over the place. So you couldn't keep a consistent number of particles. It would jitter all over the place. But the new particles are really smart, and they have an internal ID, so that gets to be consistent. So what that means is I can say, go into my emitter and say, hey, you guys now have a lifetime, 0 means infinite, but I'm going to say now you have a lifetime of only 30 frames. So now if I hit play, you're going to see that the items are falling, but then they're going to start disappearing, and it's not popping all over the place. We can now create and destroy particles and not have them disappear on us. So that's so powerful there. But yeah, there is the last way of actually making your particles become real in the scene somehow. So let's move on to the next scene file, and that is going to be, what is it? Making the liquid burst. Wait, what's this title? Making it real, color liquid. Oh yeah, color liquid burst. Okay, so this time let's walk through a little bit of what I've got going on. And it is going to be, it looks like I already got it all set up, so I'm going to delete some things here because I want to build it from a little bit more scratch. Okay, we're going to do a little bit of pulling the stuff out of the oven. Starting out, I've got some geometry, some very, very tiny geometry. If I make a figure, again, for scale, you see he's there. But now if I zoom right on up, you see I got this tiny little cloner set up. So I got all these little rings, because what I want to do is emit particles in a whole series of different orientations in these ring shapes. So instead of making a bunch of different emitters, having to do things really particular, I just art directed my geometry, and then I can make a mesh emitter. And that mesh emitter is going to respect that geometry. I put it into a connect object, it'll see that. It's going to emit from the surface, and you can see I'm going to emit about 10,000 particles out from the very first burst. So now we zoom way back out again. And just to show you, get rid of the figure. And now if I play, you're going to see that we get let me actually make the particles visible. So now if I play, you're going to see that we get a burst of particles flying out. Actually, let me delete flock, because why not? Actually, we can delete a bunch of these things out. Let's walk through all of them. We're making this up as we go. Let's hit play. Okay, you see I get this lovely just burst of particles. But one thing that's really cool is you see, look at these consistent colors that I'm getting. We're getting a band of green. And I just think those are gorgeous. Let me make them bigger so you can see them even better. So yeah, we get all these wonderful rainbow colors. And that's because there's another mode inside all the emitters, if we go into our properties, where we can not just do random, but based on a noise. So then I mapped a bunch of these different rainbow colors to the surface of the object, essentially. So the moment the particles are born, they're given this random color based on these noise settings. So we won't get any more specific than that, but you see we get this lovely burst of crazy rainbow colors. All right, now that we've done that, I want to add a little bit of variation in here. So I'm thinking let's add in some turbulence. I love the old school simple turbulence. You don't have to overthink it. Now, it's not super applicable in this scene file, but this turbulence is just a force, and it's going to apply right now. It's just hanging out in the object manager. It's not a child of anything. That means it'll get applied to everything. But the new system has this brilliant setup where if you want to limit it, if we had like multiple emitters or multiple rigs, all you have to do is grab the turbulence and drop it as a child of the actual particle group. And now this turbulence will only apply to this group. Now, I'm going to drop it as a child just to be organized here, so I know that it's directly controlling that, and I can see the order of operations. But for now, let's make a relatively small turbulence, relatively small strength, and we'll just play this a couple times. Yeah, you see this one's now spreading it out all kind of wiggly, but what I usually like doing is making a small turbulence, and I like making a second turbulence, and this one we'll call large. And this is always a really fun way of art directing these, because I'll turn off the small one, now we got the large one, and I'm going to say the scale is going to be way bigger. I'm going to try about 400%, and hit play, and let's just see. Okay, a little too big. Let's try half the size. And still a little too big. Let's do about 100. There we go. So now you see that this larger one is a little bit more coherent, and then I've got the smaller one that's making all those fine details. So we combine both of them on top of each other, and you can see that we get the fine detail, but also the big structural looking one. Okay, so now that we've got that burst going, we're going to introduce we're not going to go too in depth on it, but I think probably my favorite modifier, and all of these new settings here are called modifiers. I'm going to make a flocking modifier. Now, this is usually introduced as like, oh, the flocking modifier is for making like a swarm of birds or some fish swimming or some moths. It does so much more than that. It's practically like a collide for particles. The basic idea is now we can tell the particles that we can tell them they have cohesion, which means the particles want to hang out near each other. We also get separation, which means the particles don't want to get too close to each other either. So in this case, I think we want a little bit of both. I'm going to leave it default settings, and let's just see what that gives us. Actually, again, let's play it and see what we get without it. So here we get, you see it's all drifting apart. You see they're all kind of getting scattered all over the place. And honestly, these are probably a little too strong, so I'm going to drop the strength down to about 11. So again, let's check our baseline. Hit play. Yeah, we get those drifting apart. But you see the particles are all just drifting every which way. So now let's activate flock and see what it looks like. By default settings, we might need to change them. And we hit play, and look at that. look at how much more kind of they spread out from each other, because the separation said, hey, we don't want to be hanging out too close. And then, but I do want to change some of these settings. So we're going to say, yeah, that's fine, but I'm going to shrink the radius because I want them to hang out a little bit near each other. And then I'm going to make our cohesion radius larger. And then I'm going to, this is a velocity alignment. I'm not going to get technical into it, but I always make my radius match whichever my larger radius is. It's going to make all the particles near each other behave in a similar direction and a similar velocity. So let's go and do that again and see what we get now. And now you're going to see that we're going to start getting this lovely like little groups of clumping happening. We get these clusters, but you don't see, we don't get too many particles just hanging out by themselves. So now that we've done this, let's turn it into some actual real geometry. So we'll do that same volume trick again. So I'll say our volume builder. And again, like I said, I like remote linking into it. And now it's creating geometry. We're not really doing anything with the particle radius, so I can just manually control this. So I'm gonna make them a little bit larger. Feed that into a volume mesher. If you hold down Alt as you create it, it'll automatically become the parent of what you had selected. And now you see we get these lovely blobs. Something I really like doing is when I make these blobs, especially if I'm doing kind of a liquidy effect, I like creating a smoothing deformer. And we drop that into the mesher, and it's going to start smoothing out all the edges. We can drop down the stiffness. If we want, we can increase the iterations. Keep in mind that's going to slow it down a little bit, but now you can see we get some actual geometry here. So I hit play, and now we see the particles, but we get this big old blob, and then look at it start separating, like, oh, that's such a cool shape. And then they all drift away, but you see how they're being coherent? They're kind of blobbing together as they go, and look at how simple that was, how quickly we put that together. But here's maybe my favorite part of this. And if you take one thing away, it's going to be this type of thing. We got this blob, and we had all those lovely colors on the particles, but we lost the color. We just got this mesh. We can get that color back again. And we do that using our somewhat newly parametric versions of the vertex weight maps. In this case, I'm going to want to add onto my mesh, I want to add on the other vertex color map. So I create that vertex color map, and it's now transferring color via fields. And of course, fields are so powerful. I really want more people to get in the fields. Like, they can be a little bit technical, but they unlock so many possibilities. It's crazy. So all we have to do now is feed into my vertex color tag. I'm going to feed in the particle group itself, and the instant I do, the colors have gotten transferred from the particle to the nearest surface. Now, it's going to look a little bit jittery here. You can see that every particle is just like, or every polygon is just looking at the nearest possible particle, so they get a little bit kind of chunky looking here. But no worries, if we select our particle group, we can scroll down, and you're going to see we got a bunch of different settings, and we can do things like manually recolor them, but the one we want to play with is just switching this to average mode. And then we'll drag this probably up. Yeah, you have to make the average large enough so they can actually reach the geometry. But as I keep on going, it's going to naturally blur all the different sections it's looking at. And this now looks super clean and smooth. So that means if I go and hit play, as long as I have my vertex map selected, you can see the colors are actually transferring directly onto it. And for anyone who's not familiar, we can get this to be part of the actual real material. If I deselect, you see it disappears. It's only when we have the map. But if I deselect it, and let's open up our materials, I can double click, make a brand new Redshift material. I will apply it, move into our material, double click in any empty spot, and now I'll search for the word user, and we'll grab the color user data, which you've probably used before. Inside of there, we just say preset, particles, particle color. I think I want to feed that into both the color channel, and let's also grab a emission of 1. If you didn't know this, here's like the one tip you should take away. If you hold down Control when you're using node, either the node system or the Redshift nodes, if you hold down Control, when you click on this little dot, it will promote that setting up to these nodes. So you don't have to go hunting through those lists when you drag this link. It's like, wait, I want to link to something else, and you're trying to find it. No, don't do that. Just select the material, find the thing you want, hold down Control, and say, hey, promote up that color, and it'll just appear right there. Saves you so much time. But anyway, I want to feed my vertex color map out to my color, and I want to feed it out to the, oh, wait, that was emission weight. I actually wanted emission color, and let's feed it out into that as well. And it's still naturally shiny just from the default Redshift material. So now, oh, actually, I did the totally wrong thing. I put a color user data. That's how we get the particle color. I actually meant to make a vertex attribute. That's the one I meant, because now we can link in that vertex color map. So I feed that color out into the color, and I feed that out into the emission color as well. And now you see right in the viewport, we're getting the feedback from that map without it having to come from the tag. We just see it right there. And you're actually getting a really good preview of what the final thing would look like. So now I will visually hide the particles so we just get our final geometry, hit play, and we get this lovely rainbow explosion that's super coherent, just blobbing out. And it was so easy. So easy to put together. And we could spend a lot of time like really pushing these settings and tweaking it, but putting something together like that quickly, so much fun. Like, it's crazy. So let's close that and say no. Let's see how close we got to the original. So here's what I was aiming for there. Yeah, pretty close. Slightly different flocking settings, so you see they're kind of bubbling up in a slightly different way. I probably had the cohesion a little bit stronger. But yeah. Okay, moving on. Okay, this one's kind of fun. So we don't, of all these different modifiers, we don't have any kind of liquid simulation. I'm crossing my fingers that maybe in the future we do, but who knows? So let's go and create a brand new emitter. We'll kind of do this one from scratch. You see, the only thing I got is these plane objects, and I've got the new simulation system. I just have a collider on there. So I'm thinking, and just for scale, always good. We'll create a figure, and you can see that this is kind of a medium scale scene. He's not too big, he's not too small. Okay, so now, basic emitter. And I'm going to hit R for rotate, spin that around 90 degrees. Okay, so in the emitter, I want it to be way bigger, so I'm going to jump it to 500-ish. Just make a larger emitter there. Okay, cool. So if I play right now, it's going to shoot some particles off in the direction. I'm going to say, give me a shot of particles. And I'll say, I want to do, instead of constantly emitting, I'm going to say, on the first frame, create 10,000 particles, and then you're done. Don't emit any more particles. I'm also going to tell my particle group to display it as size 2 so we can see it more clearly. If I play right now, we should get a burst of 10,000 particles instantly. Actually, I just know that we want slightly more than that, so I'm going to jump this to, let's do 12,000. Okay, 12,000 particles. And then the last thing I need to do is say, okay, properties, you have 0 speed. Okay, cool. So 0 speed on those, hit play. Now we get a burst of particles, and they're just sitting there doing nothing forever. So now we want to start doing things with it. Well, actually, you know what? I want to add color. I always like making these colorful, so we'll switch it to noise, do the same thing again, load preset, make it nice and rainbowy. Here's a trick. If you're doing noise, you can't see it, obviously, until you emit, but if I hit play, you can see we get this noise. The noise is really tiny, and you see it's also very yellow. It's very dominated by yellow. But you notice yellow is very much in the middle of this range. All Cinema 4D noises are, they're somewhere between black and white, and they tend to be more in the middle gray. So that's mapping that Cinema 4D noise into this middle gray-ish area. So what I'm going to do is say, actually, I want a way larger set here. So I'm going to jump up to like 5,000, and then I'm going to say double my knots. You can right-click on your gradient and say double knots. I'm going to double it twice. So now, even if we're hanging out in the middle range, it's still got a lot of colors to choose from. That's just kind of a shortcut I like to do there. So if I play, now you can see we got this lovely rainbow pattern. We get all the colors, and they all are a little bit more even. So anyway, got our rainbow, but the particles will just hang out there forever. So let's start making them do something. Now, in this case, the first thing I want to do is probably, let's get some flocking going. Check this out. We make some flocking. I will make it a child, just as a good habit to be like, okay, that should only apply to this group. And let's hit play, just look at the default settings. And we're going to see, okay, they're drifting apart, but you also see they start forming these little clusters, which is pretty cool. Let them run for a little bit longer, and they're all drifting around. But one thing you'll notice is if I kind of move off to the side here, they are clumping up in 3 dimensions, which is cool. Most of the time you want it to do that, but I don't want it to do that. I want this to be like a 2-dimensional simulation. So competing for one of my favorite modifiers is this very simple math modifier. And to me, the math modifier is kind of like the plane effector. It's kind of like, okay, it's very basic, and it can do everything. So let's create a math modifier, and I'm going to say after you flock, I want you to, actually, I'm going to put math first. The order of operations does matter, and sometimes I just guess and check, but if you rearrange the order of them, they will behave differently. Which one executes before the one after? So in this case, I'm going to say, okay, I can say, do an operation. What is the operation? And we could add to values, we can subtract, but I want to use assign. That just means make it this value. And we can control lots of different properties. So we can control the age, we can control the speed, but right now we're going to control the position. And I think we want to change the position to Z, because like this is, let's see, world Z. No, it's X we want X. So I'm going to say, control the X position. So now I'm just saying every single refresh, assign a value of 0 to their position X on every particle, just again and again and again. You have to be at 0. So having done that, that's the only little change we made, and I will rename it. because you can lose track of what a math node does. So I'll just say point X. Now, if we start again and hit play, it's going to look pretty similar. You're going to see these kind of drift together and they start clustering. But if I zoom over to the side, it's perfectly flat. We got rid of the X value. But we could do things like multiply it and say it gets bigger and bigger and bigger over time. Every single frame, it would go further and further. But yeah, anyway, now we see that these are all doing this really nice job of separating out from each other. Now you see they are pushing apart, which is good. I'm not sure what values we want here, so I'm just going to guess. We'll set 1, hit play. And actually, maybe I wanted that to be bigger, so let's say 3. And I'm going to make the cohesion radius bigger, so I'll try 15. I'm just guessing some numbers here. So let these start spreading out. Okay, yeah. So we start getting to this type of thing. So you get these larger cohesions, just changing these values. Look how they're kind of like stringing together, kind of almost like this honeycomb pattern. But honestly, I think I want that to be even bigger, so I'm going to say 25. And separation strength, yeah, that's all good. So you see it starts kind of blobbing together. It looks great. Separation radius, a little bit bigger. Just guess and check until I get something that looks nice. Those spread out pretty well. Okay, yeah, I like this setting. You see they're all spreading out from each other, but they'll kind of drift forever. So I'm going to say, hey, let's add a little bit of friction in. So we got the classic force friction. So I'll say, okay, after all that stuff happens, or maybe even before, we'll just guess and check around. I'm going to say I want a lot of friction. So that means when they're born, they don't want to go anywhere, but now they're pushing apart from each other because of the flock. They have to be forced on X, and then if I hit play now, it's pulling the energy out every single frame. Every single frame is like, you're losing your energy, you're losing your energy. So you see they're pushing apart like the push apart effector, and they're not drifting too far apart from each other. So excellent, now we got a nice, pretty clean setup here. But now, how do we make it look like a liquid sim? Well, we've already kind of did all the stuff that we needed, except for adding in some gravity. So we'll drop some gravity in there. I'm going to pull it way down so it doesn't run too quick. And now hit play, and now all those are going to fall to the ground. Oop, I forgot what we need. One less modifier, and that is going to be a collide. We have a collide modifier, and that means that it is going to respect all of these different simulation tags. And that could be on a cloth, it could be on a rigid body. In this case, it's just on a collider tag. So hitting play, you see these all fall, and now they are going to start colliding with these surfaces. But one thing I do want to do is select all of these surfaces and say, hey, collide with both sides, please. And now those should be getting a little bit more stuck. And now you see them start punching through. Okay, I don't want them sneaking through there, so I might need to rearrange. Oh, I know why that's happening. It's because the flocking is coming after the collision, so I'm going to say the very last thing that happens is the collide. So now let's see. And this goes back to what I said, where you see it is now behaving differently because it's trying to collide after the flock had pushed them apart from each other. So just by switching that, you can now see these start to fall, and look at this. Look at them start to flow in all the directions. They're trying to stick to each other, but they don't want to get too close to each other, and they just start flowing around. And it's really fun and fast to play around with this stuff two-dimensionally, because it's going to be running way faster for testing purposes, because I don't need like a million particles filling up a big giant volume. It's just like a cross-section of it. So right there, of course, that gets super fun. One thing you'll notice, though, is we're getting a lot of kind of squishing of the particles right there. So let's run that again. You can check them out. As more particles are squishing down above, you see it's really collapsing on top. Well, there's one simple setting that will improve that. If I hit Control or Command D, you can go to your particle, or you go to Simulation, Particles, and there's not too many settings here, which is good. It keeps it nice and simple. And we have a single setting here called substeps. So I'm going to set our substeps for the particles up to 2, and then hit play, continuing, and watch this area right there. As I hit play, you suddenly see those push away, because now it's calculating more accurately. I have found if we do about, 32 still. If I do about 3 substeps, that's going to do a pretty dang good job of keeping those separated really nicely without slowing us down too much. And now look at this lovely simulation that we're getting as they push apart from each other and they don't get too squished. So just, again, play around two-dimensionally because it's such a fun playground to be in. And yeah, there's my nice, simple little liquid simulation you can do. Again, playing, and that's flocking here, essentially behaving like some sort of collision detector. So we'll close that one up. Let's see how close we got to the demo file that I had practiced. Hit play, lots of colors. Those fall down. Oh, yeah, pretty close. I used a different noise pattern on that one. Oh, there they go. I kind of like the new one even better. Okay, moving on. We only got about 15 minutes left. So which setting should we do? This one's fun, but it's going to take a while to explain it. So I might actually open up the final file and we'll just talk our way through. So this, oh man, there's such cool stuff in it though. It's always such a struggle to compress so much information down into like a 50-minute presentation. Okay, So this one is dealing with a lot of collisions. And you see I've got a lot of modifiers here. I've got multiple groups here. I really don't want to skip over all these details, but I would like to cover more stuff. So this one's doing a lot of interesting things, and I'll talk through it. If I hit play, you're going to see that we get this emitter, and it's spitting out particles. And I've got I've got collider set up, and you see it is colliding with the ground. Now what's cool is the collider has the option to, in the moment it collides with something, switch it to a different group. So I've made a different particle group, which is this one. So it's going to switch, on the moment of collision, it switches over to this. And then I've got a math here set to set the speed to 0. So instantly it says, stop all your speed, don't go anywhere. And I've got another math modifier, which I should be naming these. This math modifier is saying it's got an age, and saying, hey, your age, no matter what it was, is going to be reset to 0. Like, it's almost like you're a newly born particle. And then the instant that applies those two things, I'm going to say switch a group again. So it's kind of like this is being treated as a one-shot. Like, things just instantly got applied, and then the particles moved on to another group. So now in this new group, it's going to start doing different things like, because they're now being treated as newly born particles, I can do things like, hey, use a data mapper to remap the age. So I'm going to say from 0 to 15, make the radius go from 1 up to 15. So you can see, because they're acting like they're newborns, as these collide with the ground, I'm getting these ever-increasing radiuses. Like, the circles get bigger and bigger and bigger. And I'm also saying, I'm going to turn off this blend. We don't need that. We've got a color mapper, and the color mapper is saying, over the course of being the age of 0 up to 400, go from yellow and slowly get to be a darker and darker green as we go. So you can see that when these strike the ground, they start out as yellow, and they get bigger, and they get more of a dark green applied. And then we've got this flocking behavior, so they're pushing apart from each other, just like we had in the liquid sim. And I've got actually, let's turn off those, and we'll get back to them. We got friction, which is slowing them down. Scrolling down, and I've got final condition here, and that's just telling them they can't go below the ground. If they reach Y, they just hang out there. Okay, cool. Having done all of that, here's the novel part of this setup that I really, really love that we can do this. Inside of I've got a volume builder, so I can activate the volume builder, and that's being fed the particles, and it's respecting the radius. So you see, there we go, we got that. And I'm going to say, make it into a real geometry. Excellent, we got that. And if I play, let's hit play again and just see what we got. So now we're just seeing that final geometry. I'm also putting the colors into the color vertex maps. That's being fed to the materials. So you see these get bigger because they grow up. You can see the volume builder kind of scales them into existence, and we start getting this blob going. And yeah, they're all just blobbing, blobbing, blobbing. Let me turn off the, oh wait, the collider would make that happen. I guess so, yeah, I guess they're already colliding. Here's the important part and the fun one. I have added on, actually let's delete that so you can see. Here's all the particles falling. They're going to hit the ground, and they're blobbing. So they're kind of spreading out. They will spread out as soon as they hit the ground, a little bit like a liquid. As they get bigger, they'll push each other away, and you see it kind of spreads out. It gets a little bit bigger as it goes, and it's just kind of blobbing on the ground, which is kind of a cool effect already. Like, that would be something that would have been tough to make. And you can see the new particles are that lighter color, so that's neat. But what I'm going to do is add on a simulation collider tag onto the geometry that's being created from the particles. So let's make sure that we say it collides on both sides. We don't need any bounce or friction. So now if I hit play, the same thing's happening, but it's not only colliding with the floor, it will also collide with the blob. So what that means in this context is all of the stuff is going, when it collides on top of itself, let's see, look, it can start stacking upward because it's self-colliding. So this will keep on building like crazy and crazier blobs, like stacking up on top of each other. So from there, I can reactivate the flocking, and that's going to have them spread out from each other. So suddenly we got this living blob that we're colliding with in real time. And then it's just going to keep on stacking and stacking and stacking, getting crazier. Like I just love the effect so much. But then we can say, hey, let's add some gravity on there. And now all of them are slow. It's a very, very mild gravity. So all of them are always kind of blobbing down to the ground and spreading out because of the flocking. So now, this is a very silly example. I don't know if anybody would ever need this effect. But the idea of like, oh, a particle has landed somewhere, it becomes real geometry, and then I collide with that real geometry. But all of this is using the volume mesher. And keep in mind that in the volume mesher, in the volume builder, this is being additive. But you can imagine, like I did in my What's New video, you could be doing this subtractively. It could be punching a hole through the floor by subtracting out the new geometry you're creating. So you could be destroying some other mesh by creating additional particles and that collision. So just so much fun to layer these up on top of each other. And then, yeah, here I could also smooth out the mesh, and I added in this kind of displacer on top of it. So these are kind of like writhing and boiling underneath as we get the collisions. And it's always colliding with that final geometry, so very fun to make this. Okay, so that was the goo example. I honestly don't think, we've only got about 10 minutes left. But I'll just hit play on here. Something I always suggest to everybody when you're trying to learn a new particle system is just make some fireworks. It's such a straightforward way of like stretching the muscles of it for you to learn. And it goes for any software package, no matter what you're using, whatever software you're using. If you're using After Effects and you want to make some particle stuff, try and make fireworks. And by the time you're done making fireworks, I feel like you now have a pretty good grasp of the particles, having different goals. So I'll just kind of walk through this one a little bit. We've got a very basic emitter, and it's existing right here. So I'll turn off these subsequent ones. So pretty straightforward. I'm just saying, hey, emit, choose a random color, keep on very slowly, over every second, emit 5 particles. And if I play, the only thing you see is we get one little particle, and you see each one's its own little color. I should probably make that a little bit bigger so we can see them. Hit play. Oh, make them way bigger. Okay, now you see we get these little ones, and they fly, and they die eventually. But I'm going to say, okay, you're going to have this little tail. So we're now using this reproduce, and the reproduce is going to reference, well, you see it's a child of that group, so it's automatically referencing it. So now every single, it's constantly, per particle, creating 75 new particles, and it's got cool properties like, let me scroll down here, color. If we go down to color, if you twirl down the color, if we twirl down the color section, you can see you start getting settings like inherit the color. So the reproduced particles can take on the properties automatically of the parent. So I'm saying, hey, you're mostly just a nice bright white, but take on 39% of the color of the parent. So if I hit play, you're gonna see each one of these has its own custom tail that's very pale, very pastel now, but the yellow one has a slightly yellow tail, and this one will have a brighter. Let's crank up that color inheritance so it's way stronger, and you're gonna see the tails are now taking on a way brighter color that's matching the firework even more. Pushing even further, we can create the burst effect. So, and then down here, I'd have another burst tail, so I'll get rid of that. So now, this burst is saying that on the moment, on the condition, we didn't even get to talk about conditions. There's so much to talk about with particles, it's crazy. There's now a condition that's saying when the age is 100%, you can now create a new burst of particles. So you see we get these nice simple bursts, just a big burst of particles by saying create it at a super fast speed in a random direction. It's taking on all the saturation of the original object. And then finally we can say, hey, when these like bursts are getting created, also put a little tail on them. So activate that and you get these lovely colorful tails, all those colors and properties propagating up through the entire system. I would have loved to go and make this from scratch, but it would have taken like the whole presentation. And if you want to see more of this, there's so many more cool tutorials to make with this, so expect more stuff from Rocket Lasso. So now moving on, just a quick reminder that, yes indeed, we are having that sale still, so head on over to Rocket Lasso's Gumroad, and if you use code NAB2024, you get 25% off any of our plugins. And let's jump back in and check this out. I wasn't able to talk about this because my computer at home is getting way older and the video cards just are not up to snuff anymore. So Pyro started running really slow on my 8-year-old machine. But now I wanted to show off that we can do Pyro advection, and it's really simple to use. So hitting play, you see I've got some nice simple, actually let me reactivate. In my simulation. Oh yeah, I want to do density first. Okay, so if I play, I've turned off fire, so I've just got smoke, and the only setting, this is all default on default sphere, and it's just adding that pyro tag. The only thing I did is I said the smoke is really heavy, it's really affected by gravity, so it's pulling it down. So you see, there we go, we get smoke, and it's just falling down. So now I'm going to say, just create a big old emitter here, and let's pull back on that a little bit. And so I'm going to, in a single frame, create 100,000 particles. And I don't want to see the smoke, so I'm going to go into my pyro scene, twirl it down, go all the way to the bottom, and say, hey, don't draw the pyro. So now, you'll see I'm going to get a burst of, I suddenly got a burst of 100,000 particles. You know what? I think we can go harder on it. Let's say 1,000,000 particles. So we got 1,000,000 particles, and we're running off a laptop right now, so you see some of the speed of the system. If I play, we're going to get 1,000,000 particles created, and now all I have to do is say, create a pyro advect, drop it as a child of the group. That's all I have to do. I'm not even going to change any settings. And now we hit play. And now that is going to be affected by the movement of the smoke, and we instantly get this beautiful effect of it falling down along with it. So I just love how quick that is. That's 1 million particles moving right along with all the pyro. So a quick modification on that. Let's go and activate. All I'm going to do is go into Pyro and say, hey, give me the fire again. So I will activate my temperature. I'm not going to turn the Pyro on again, but essentially it's going upward now because of the fire. So now if I hit play with that updated Pyro, you're suddenly going to see that it's getting pulled up along with the fire, and we get look at these beautiful curls and everything twisting around. Oh, so good. And now even with that, keeping it as simple as possible, we've got things like this color mapper. And yeah, actually, we'll just do it from scratch. Another one of our modifiers is called a color mapper. I can drop that as a child and say, hey, what property do we want to look at? I want to look at the age. So I'm going to say the age up to 333, and it's now going to be mapping onto that gradient. We can make this like any colors we want. Let's pull it off. There we go. Kind of a crazy red to blue there. Let's run that again and hit play. And now you see the particles are getting recolorized, and it's all going to be based on their age, although it's probably a little bit too long for there, so let's change that to like 90 frames. I'll say 45, so we can really see it. Now as I hit play, the age of the particles is taken into account, and they're all going to shift their color. So that's pretty cool out of the gate. But even more fun is shifting that maybe to the overall velocity, or I'm going to say distance traveled. That's even more fun. So how far has the particle traveled is just a piece of information we always have. So now I'm remapping the color based on how far from 0 to, I'm just guessing, 333. And hit play, and now the further a particle travels, the more the color gets remapped, and look at this beautiful liquidy effect just going further and further. And once it goes beyond 333, it'll just maintain that color forever. So, I mean, look at that, just 2 simple modifiers, create 1 million particles, and then we instantly get this animation. Like, that's straightforward. And like I said, this is running off of a laptop, so like incredible. Like, this is such an amazing addition to cinema. This is another one I'm gonna have to, like, unfortunately, fast forward through. Again, I could do a 3-hour presentation easy. If they said, hey, the next 2 presentations got canceled, I'd be like, I can just keep talking, no problem. Anyway, I was going to do this whole setup where we're creating this big fancy, oh yeah, it's not even in the scene, so I'll open this one up. So there's these really cool things that you can do with volume builders where you can kind of create these really complex directional trails. And the basic setup here was just going to be, I was creating a kind of flock of these arrows. I'm just cloning some arrows on. And those arrows are now going to follow kind of all these directional lines. And that's just happening thanks to a field force. If you guys don't use field force, you got to start learning how to use field force. It means you can use fields like wind, and you can do anything you want with it. It's how you turn it into like a real motion graphics tool, because you can start making them follow the direction of splines and like traveling around text or getting attracted to text. There's like so many things you can do. But right now, yeah, these are all just going to be drifting around, and I'm also somewhere here, I'm using a flock to make sure none of those get too close to each other. So now you get this natural kind of traveling in all these different directions. Well, you know what would be cool, instead of just having some little arrows here, it would be cool if we had some character animation. So what if we make a whole army of T-Rexes, and in the cloner, there's this amazing setting called map the animation. So I'm taking the keyframes, and I can map it onto the age, so they'll just naturally play. Or I can say, hey, based on the distance they travel. So even though all those arrows would be moving at slightly different speeds, they are now going to be mapped onto how much distance they've traveled, meaning if I hit play, we've now got a very basic crowd simulation going. And not only that, these are all offset from each other. If one T-Rex walks faster than another one, their feet will be synced up differently. So suddenly if we did double speed, they'll suddenly be walking twice as fast, because I just kind of eyeballed, making sure that this distance, about 75, looked like they were actually properly taking steps. And you see if I zoom out there, we get this nice flow where it's like look, they do move in herds. So yeah, super fun to do even a very basic particle simulation or a very simple crowd simulation here. And you could be dropping into the motion capture data. This is just a baked alembic there, but yeah, walking on top of these simulations. So we got 2 minutes left. Is there any one last little something I can do? Spinners, definitely don't have time. Yeah. So here's just a simple one. I mentioned this in my What's New video. Here we've got another 2-dimensional flow of particles just kind of traveling all over the place. But on this plane, I could right-click and add one of those color vertex maps again, and say Other, Color Vertex Map, and it's easy to be like, oh, we just projected the color of the particles directly onto like the big blob we had earlier. But if we drag it into something like this, let's drag in the particles. you can look at, oh my God, look at this like instant kind of Voronoi pattern that we're getting of them flowing around. I actually hadn't done that before. That looks really cool. Because what I've been usually doing is saying, like average them out based on a distance and then making the radius really tiny. Now you can see we get these little dots. Like this is now like on the mesh. The color's been translated over to it. But from here we can use any of the fields that we like to play with. So going into this menu, we got some of my favorite ones. And in this case, I'm going to create a field decay. And now I'm going to say, hey, you've got a lot of decay, and I want you to, and now you see that it's looking at the colors and making a little tail travel around. And even though this entire thing is it's two-dimensional, it's flat, you can see from the front, don't these feel like they're kind of moving towards and away from the camera? Like, so much fun, just being able to translate these things. And you can imagine from here that we can use that data however we want. We could be colorizing it, putting it into a material, but that could also be a displacement map where anywhere that the particles are traveling over the surface, it's getting displaced. We have like completely like modified geometry moving based on any of our regular deformers or translating these vertex maps into different animations, translating those into different espresso setups. Like the raw data we get from these live vertex maps, it makes so many things in Cinema 4D like universal. They can just get translated everywhere. So I should mention that I'm going to be hanging out in the back of the booth for an hour. So if you have any questions, especially about any of the new features in Cinema, I know we only covered particles, but there was even like more cool stuff like the property transfer and all the new connectors. Like there's so much to talk about. We don't have time for the spinners. But anyway, here's just a visual of the final of it, where I have these individual particles like traveling and then randomly curling, so you can get very specific behaviors from them. But anyway, we'll just close that up. And once again, one last time, remember, Rocket Lasso has a sale just through NAB, so you can get 25% off any of our tools. Use code NAB2024. And then I'll just say, thanks everybody for watching.
Great job, Chris. As always, questions from the audience. Live questions get priority. Either you're stunned or confused.
Yeah.
One of the two.
Yeah, one of the two.
I'm going to go
fast.
with the first one. It's good. It's a good silence. Everybody's just like, yeah, he taught me everything I need to know right now.
Well, I know that's always the case because when I go to the back of the booth, people are going to come over and ask me the questions. But you could ask it right now, you know.
Yeah, you could get your question answered on the big screen, but that's okay. Oh, here we go. There's a one brave soul.
Oh, yeah.
Okay. You want to go over that question again, or you want me to?
Yeah, I can say it again. So essentially, when we go back to that, and I don't know that I could specifically demo it, but it's like with a fireworks scene, could we make it maybe take on the form of some sort of shape? And that could be like almost any element of it, where maybe the initial explosion, like the particle traveling around, like that could be traveling around some sort of spline. And we could do that instantly with a field force. Or actually, it would all be with field forces, but yeah, you could totally do that. And you could do that on any specific group that I made. So it could be just like the secondary explosion, that will only be filling a shape. And we could say, hey, if the particle exits a volume, delete the particle. We could say, hey, those get attracted only on the inside. We could put it inside of a mesh with a collider, and as the particle explodes, they'll bounce around inside of the mesh or only outside of the mesh. So essentially, yeah, there's a million ways that you could be like, oh, okay, I want to represent that, but only within, say, a logo. You could make it so that it's intersecting some text, and the particles that are inside the object, colorize them to be brighter, but the particles that are outside of the group have them fade out a little bit, or they get smaller. So like literally, artistically speaking, you make any combination of those. Yeah, total control.
Other questions from the live audience? All right, so what do you mostly enjoy about the particle system and the field system in combo, or is there anything else that you're like dying to have in that?
Well, for me, I mean, the obvious ones are let's open up a new file. The obvious ones are the flock, and we didn't get a chance to talk about it, but Predator Prey is so much fun. It's almost like you can build your own little video game simulation inside of it, and you can get crazy, where you have like, imagine like a wolf model chasing a sheep model, and then there's a bunch of wolves and a bunch of sheep. As the wolves get more hungry, they start getting faster, and if they catch a sheep, they suddenly have baby wolves get born, and those start running around, and then maybe the sheep are trying to eat other particles that are grass, and you clone the grass on the different areas. And like you have a whole simulation game that you could build. So yeah, that's super fun.
When do you drop that game? When is that? Okay.
I made the basic one. I just didn't put the animated sheeps and wolves.
So see them in back if you want to play sheeps versus wolves. It's going to be a pretty
Yeah.
fun game there. Thank you, everyone. Let's give Chris another big round of applause. He'll be in the back for the next hour if you have questions. Stay tuned, though. We're going to take a quick break, and we'll be up next with the one, the only, Jonathan Winbush.